Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will discuss how to apply law of conservation of momentum when there is no any physical contact between two isolated bodies. And this concept I will explain you with the help of past paper question from Cambridge ES Physics. First of all, let's try to understand what is given to us. If we read this question carefully, it is given to us that there is a rock R of mass this much. The mass is given to us and is at a large distance from a star S. And the rock is traveling at the speed of the rock is given, and mass of star is also given to us. And rock reverses its direction of motion and has the same speed as initially at a large distance gain. If we look at this diagram, it is also given to us. At this point, we have this rock. It is at a large distance from this star. So this S for star. And the speed of rock is given, mass of rock is given, and mass of star is given to us. And the speed of rock is also given here. So at this point, rock is moving to the right, and here rock is moving to the left. Now what we need to find out, simply we need to find out which statement is correct. We have four options. We have to choose the right one. Now in this case, if we study this system carefully, one thing we can conclude is that this is isolated system, as there is no any other object in its surroundings. So we can treat this system as an isolated system. And also the second thing what we need to understand is that in this system these two bodies are interacting with each other. So this is a special kind of collision. So we can also write down this is a special kind of collision in which two bodies are interacting with each other. So this is second thing we need to understand. Now as we understand now, it is a kind of collision in which bodies are interacting with each other and they're exerting force on each other even there is no any physical contact between them. So we can use law of conservation of momentum. So let me explain to you first of all few important points, and then we will use those points and we will answer this question. Let's say we have two objects. Let's say we have object X and we have another object. This is object Y, and these two objects, they collide with each other. So the Y will exert force on X. We will say this is force on X by Y, force on X by Y, and there will be force on Y by X, force on Y by X. So I will simply say this force Fx, and this force I will simply say this is Fy. Now these two forces, the magnitude will be same, even the direction is opposite. We can simply say Fx is equal to Fy, the same magnitude. They have same magnitude, even direction of force on these two objects is different. Now second thing we need to understand, the time of impact means the time force Fx is acting on X is the same as the time for force Fy acting on object Y. So time of impact is also same. Now if I write like this, Fx Tx, this also will be same as Fy and Ty. And Fx Tx, if we remember, so the product of force and time of impact, that is called impulse. So we can say impulse is also the same, the magnitude. So you have to be very clear here. We are simply talking about magnitude. So magnitude of impulse on X and magnitude of impulse on y is the same, but direction is different. Direction is opposite, but magnitude is the same. Change in momentum. So the change in momentum for x and change in momentum for y is also the same. Magnitude is the same. Even the change is in opposite direction, but magnitude is the same. So this is all what we need to understand. If you're very clear about this one, this question is very simple to answer. Now, first of all, let's look at option A now. What option A is telling us? Option A is simply telling us the change in momentum of S is in direction of arrow X. Means the change in momentum for the star is to the left. So let me redraw here. So this one is over star. We can say this is S. At this point, the rock is at this point. So this is R. So the rock is at this point. Now, between these two objects, there is gravitational force. So the rock is pulled to the left and the star is pulled to the right. As the resultant force on star is to the right, so the change in momentum also has to be to the right. So the delta P, the change in momentum for this star, it has to be to the right. But option A is telling us it is to the left. So this is not right option. Now let's move on to B now. The change in the velocity of X is approximately 20 meters per second. So this is based on calculation. We will do calculation later. Let's move on to next one. Option C is telling us the magnitude of the change of momentum of R. Magnitude of change of momentum of R is 10 to 3 times greater. No, that's wrong. This is not right, because we have discussed the change in momentum in magnitude is the same for two interacting objects. So this is also not our answer. Momentum of R does not change. But momentum of R is changing because momentum is a vector quantity. So even speed is the same, but velocity is changing. So momentum is changing. So this is also not right answer. So our answer is B. Let's do calculations and find our answer. We have already discussed that the magnitude of change in momentum for rock and also the magnitude of change in momentum for star, they are the same. Now simply we need to calculate change in momentum. Now first of all, let's try to find out change in momentum for rock. As you can see here, at this point the rock is moving to the right and here the rock is moving to the left. Now we need to find out change in momentum. As momentum is a vector quantity, so we need to decide one direction as positive. So in this case, let's say to the left is positive. If we take to the left is positive, we can also then this velocity will be negative and this velocity will be positive. Now we need to write down the change in momentum, so we can say this will be V minus U, and for the star we will simply write down the mass of star and we will just simply write down delta V, because we need to find the change in velocity. So this is our change in velocity. This is what we need to find out. Now in this case the mass of the rock is given, so we can just plug in values. Mass of the rock is 1.0 times 10 to 27 kgs, and the V in this case, this is 1.0 times 10 to 4, this is plus, minus, and as this initial velocity is negative now because we took to the left positive, so we will plug in here, this is minus, so this is minus 1.0 times 10 to 4, and here we have mass of star, that is 1.0 times 10 to 30 multiplied by delta V. Now you can see here, if we little simplify this one, so we will get this is 1.0 times 10 to 27, and here we have 1.0 times 10 to 4 plus 1.0 times 10 to 4, and this is equal to 1.0 times 10 to 30 times delta V. So from here, if we just plug in these values in our calculator, we will be able to get delta V, that is 20 meters per second. So this is our correct option.